All right, take it away, Ozzie.
Today I want to go over a lot of things. This is very much a high level view. That seemed like a good place as any to start, but of course there's a lot of details in any of the specific subsections. So if people have questions, I could go more into detail. The title of this is Estimating Everything Everywhere Always, an ambitious and symbolic paradigm for scalable estimation. So very quickly, people may be very familiar with other forecasting platforms. Right now we have Metaculus and Manifold and Good Judgment Project. There's a pretty diverse space right now, but most of them look kind of like this. Most of them have fairly straightforward questions with either probabilities or probability distributions. When a lot of people are thinking right now about how to do a better job, they're thinking about things like this, but with higher accuracy. In comparison, I'm thinking about something a bit more like this, right? Myself and others at Query are trying to think about what a much more ambitious paradigm would look like. How do we take these concepts that we have now and use a lot more software to do them in a much bigger way? So going back a bit, this is what we're doing at Quantified Uncertainty Research Institute. If you want to know more, just go to that URL on the bottom, which will lead you here. And then if you go to content, you could see a big list of many of our blog posts, which span a variety of topics that are basically filling in this broader agenda, even though the broader agenda may not be visible by reading the posts by themselves. We also have a newsletter, and both of these guys are free. Basically, everything that we do is free, including the software. The term that I'm kind of using for this now is estimation utopia, as like the pseudo term. Basically, like imagining a world where we use parameterized estimates to make a whole lot of decisions, and things are improved because of that. Very arguably, if you think through different situations, that could help a whole lot of problems that we have. For example, a lot of diplomacy and negotiation or coordination could arguably be in large part reduced to questions of estimation if you're a bit clever in how you do that. So correspondingly, if we can estimate things well, if people could trust those estimates, there's a lot of good stuff that we could get. There's, of course, a big question of, are we going to get AGI by this point? Like, if we're going to have AGI in 10 years, what's the point of imagining some cool agenda before then? So there are, of course, some trade-offs over there. This is kind of expecting that it'll be valuable and feasible to do useful stuff before we get to full AGI or transformative AI. Part one, advanced estimation systems, just an overview of what that means. When we look at the information that people care about, there's a spectrum between the objective to the subjective. Objective typically means empirical stuff that we have a lot of tools for. This is where data sets come in. A lot of engineering paradigms are built on stuff that's pretty objective. On the other hand, though, we have subjective information. And frustratingly, a lot of the information that we often care about is pretty subjective. So in between our common estimates, there's this broad spectrum. Some specific examples, like in data, very clear facts about Acme Corp. Of course, everything is a little bit subjective and objective to some degree. Then you have estimates. So a lot of different people don't agree on estimates as much, but there's still some agreement. And of course, we have some clarity on how well prediction systems seem to be able to handle specific classes of estimates. And then on the extreme end, you have questions like how valuable was Acme Corp in the world? And these are typically classified as highly subjective, highly normative. But the frustrating thing is that a lot of these questions matter a lot. Like when we're trying to decide what to do as EAs, much of our decisions has to do with these very subjective questions. So it would be a pity if we can't use all of the great infrastructure that we have for the more objective stuff and apply them to the more evaluation-based questions. So a lot of the question here is like, what kind of infrastructure and tooling can we use to make the most out of estimation and evaluations? I'm calling this like very high-level estimation systems, which are things that like basically take in capital and output estimates. First approximation, what we care about is accuracy of these estimates. And then correspondingly, that means that we care about the efficiency of this pipeline. So different forecasting platforms could be evaluated based on how good they are, just like accepting money and getting accuracy. Some examples, so arguably hedge funds, a lot of what they do is just convert human labor into estimates. It is a bit more complicated than that, of course, but that is like a big chunk. Prediction markets do this in a more straightforward way. And then think tanks and different analysis groups, this is a large part of what they do. They often spend a lot of time writing descriptions and stuff too, but hopefully they actually get correct answers. That is a pretty big part of what they're supposed to be doing in a lot of cases. But in the future, what we want is much more efficient versions of this. So are there versions that for every dollar that they ingest, they 10 times as many questions with the same amount of accuracy or the same questions with dramatically more accuracy? And hopefully a few orders of magnitude higher than that. So the two broad approaches to this, number one, we could try to just use AI for the whole thing. That's like the AGI paradigm, or just asking GPT-4 for everything. The other one, of course, is using AI combined with some kind of world model. I think at this point, it's kind of, overdetermined that AI is going to be like a really big part of the equation. The only question is it going to be the only part? Or is it going to work with other parts as well? And if it does work with those other parts, like what do those other parts look like? Those are arguably the more interesting thing for us, or at least that's been my focus area. So thinking through what this would actually look like, Basically, there are a whole lot of bottlenecks between us and great estimates that are actually making decisions in the world in ways that people care about. This is one way that I've been breaking it down of what I imagine one large paradigm looking like. So on the left hand, we have background. So epistemic foundations basically means that if you have an estimation system that's useful for decision making, if you believe that the Greek gods are accurate, then you'll try to be making estimates based on the ancient Greek gods, and that'll just like lead you astray. So you do need to have pretty good understandings of how to begin parameterizing the world in order to actually start that process. Epistemic culture, that basically means like how much are people actually accepting the truth? So for example, if people come up with great estimates about how valuable every future potential president is going to be, but then people just dismiss that because it doesn't match what they would like to believe, then we can't get that far with that type of work. Similarly, with an EA, hypothetically, it may be very valuable for us to estimate the value of different projects, but if people are going to push back on that and fight that, it may make people very nervous. In that case, obviously, there's not much we could do if people are just going to be upset by it. There is a broad spectrum here with how much candidness different cultures allow. So typically, Israel is on one extreme of being pretty extreme about being able to be open for feedback and very candid. On the other hand, I think on the power distance ranking, some other countries like Japan are known as being lower and that you're not really supposed to talk up to your boss if you have a problem with them. And that translates to other parts of the culture. EA is probably somewhere in between, but we definitely like arguably what would want to be is much more extreme than even Israel. So as long as that happens, there can be different limitations and we have to figure out ways of dealing with that. Another aspect of culture quickly is like sophistication. So if people understand and could appreciate the value of forecasting tools and probability distributions and how math works, then they're going to be able to better discern the groups that provide value. If they can't, then there's a lot of techniques that we're just not going to be able to use, right? In terms of components, I'm trying to give a quick summary. So prediction is basically what you have with forecasting platforms like Metaculus. So think of prediction as individuals just submit forecasts and then score the forecasts and aggregate the forecasts. Calculation means how much do people actually get to reuse code. For example, if someone in Metaculus uses an Excel model or something like that in order to calculate the results, that would all be an example of calculation. Hypothetically, we could have much more rich environments where people have calculation tools that automatically adjust a lot of their forecasts for them on Metaculus. That'd be a case of a much more sophisticated set of calculation plus prediction. Right now, the tools live in pretty different lands to each other, but there's definitely a lot of work to combine them, especially if we want to upgrade these to handle way more questions. And one example of that is on Metaculus right now, there may be 1,000 questions, maybe a few thousand. If we wanted a similar number of people to handle a much larger number of questions, we'd need pretty different technologies. So some of this is trying to imagine how do we get from here to there. The third group is ontology. That basically means that we need a list of definitions, and that also I'm intending for that to also include data. So basically, if people are going to forecast the chances of nuclear apocalypse or the chance of a nuclear attack, there needs to be a very good definition for what a nuclear attack actually is. There are many different types of nuclear weapons, so that definition is actually quite vague. More importantly, perhaps, is like we hypothetically just need data sets for things. So if people are going to have, say, repeated estimates on which companies are going to make transformative AI or what the future market cap of AI companies are going to be, then it's great to have like real-time or, decently updating data sets for existing, like historical data sets of companies already. So both data sets and great definitions seem like a pretty useful thing as you scale up. And then the last one is evaluation. And this kind of is what helps us get into evaluative questions or questions that are much more normative in nature. So without this, a lot of forecasting platforms right now are used for questions that are very empirical, like what will the GDP of this country be like in 2025 according to Wikipedia? But often we care about questions like how valuable is this kind of project going to be? Or these like much more broad questions. And it's harder to resolve them. However, one way that we have of resolving them is like setting up expert panels or things like that, that could give us a decent judgment. Now, of course, those expert panels are going to be kind of biased, and they're not going to be perfect, but this arguably allows us to do better than we would otherwise. The different ways that this could work. So for example, one way is that we basically imagine we're trying to judge how valuable a safety paper is. We could say that in 5 years, we're going to have a panel assembled of 3 top professionals that's going to judge, like they're going to spend 10 hours on it with a helper or an assistant, and they're going to make their best guess at that point. And basically forecasters right now would be predicting what they would say. One really convenient thing here is that you don't have to do this every time. So in order for incentives to be compatible, you just have to do this without the forecasters knowing when it's going to happen. Of course, to have a quality resolution, you do want it at a pretty decent frequency. So this would be like, maybe people are estimating how valuable 1,000 projects would be conditional on being evaluated. And then in only 1 out of 100 cases are actually evaluated. And then the corresponding forecasters who are accurate on those cases get paid out. A different way that this could work, of course, is like instead of having expert panels, we could have basically some kind of effective like EA jury duty, where we try to say these forecasts are meant to be estimates of what the readers of the forecasts would think after some deliberation, or after being like enlightened, as like economists may use. So in that case, we just like would randomly sample some of the population who seems like the population who looks at these questions, and then choose them, and they go for several hours or so to deliberate on a very small subset of questions, and we see what their amplified judgment would be. One way, of course, of making sure that these people are doing a decent job is to say that what they're actually doing is they themselves are making a forecast of what an even better group would be a few years down the line. So it's kind of turtles all the way down. But eventually, hopefully, we could get to AGI, or at least ways that we could be pretty decently confident. The specifics of how that works, of course, there's definitely thinking to do to make sure that that's like something that we could expect to be unbiased. But I think that there's a there. And then domains, basically we need to now figure out how to apply these principles to each domain. That typically means like, how do we parameterize information about each one in a way that could be estimated pretty effectively, and in a way that is actually going to be decision relevant as needed. FHI uses a bit to describe basically big picture type work. So figuring out how big are all the biggest risks compared to each other, and like what things should civilization as a whole do about them. But still, it's not very well defined. Also, this domains I wouldn't pay too much attention to. It's a background and components are probably the much bigger thing. And then domains are more of an example of how they could be applied.
David Reinstein has a couple of questions in the chat.
Oh, sure.
The whole presentation here is very abstract at this point. And maybe you could ground it a little bit in what exactly is the problem you're trying to solve in the near term, and how could you apply this concept? I might have missed about 10 crucial sessions of your presentation, and so I apologize if you said it in that point.
For one thing, I think one decently concrete example right now, like on Metaculus, on Manifold, we get these very idiosyncratic sets of questions. But in the future, we probably would like to ask questions like at any point in time in the future, what do we expect the market cap of all the top AI companies to be? Like how much computation doesn't exist at every point in time? Maybe we want these, arguably these are very expressive questions. Also questions like how valuable is every single forecasting question, as would be evaluated by several different committees that we could come up with, right? So these are just very ambitious questions to ask, although technically, like you could have programs do it, but we need the infrastructure to make that into like a doable thing.
Fair. And if I could just add one more thing, suppose you've built this paradigm, and what's sort of the next step with the thing you're building here? Are we going to get agreement on it and then operationalize it in some way, or is it just feeding into what Curie is doing in terms of a certain building? And maybe you get to that later. So it's just, I have curiosity about these things when I'm seeing what you're presenting now to understand how to do that.
There's a lot here, and I'm trying to go through it quickly. That's why I like questions. And I think in a better world, what I'd like to see is something like the art, in a similar way that like Metaculus doesn't have formal buy-in. Some people decide to trust it because they know that that's a reasonable thing to do. And then we spend a fair bit of money and time trying to make sure that there are good questions on Metaculus that are decision relevant for people. I would expect that to be scaled up. So for example, if we had a list of how valuable everything in EA is, as judged by one council, and if people like semi-trusted that council, I'd expect people to start taking corresponding actions. And then if you could do a good enough job with these systems, then eventually that will get encoded into different formal things, like payments may get out. People may say like, oh, if the prediction system says that your project is over this good, then we'll just automatically send you a check, right? So basically, the more work is done to make strong sets of formal predictions that are useful to people, the more I'd expect that to be like used in society. But this is definitely like, we have a long ways to hypothetically go. Big goals, number one, just make very scalable, big estimates on almost anything that could be parameterized, very easy and general purpose. And number two, figuring out how to then take that and apply it to domains in order to create a lot of value. Of course, number one could be used for number two, right? You like have people estimate, like, oh, for these 20 different ways that estimations could be used for problems, what's expected value of each one? You basically have a collective reasoning system. So it could do anything that, a lot of the things that you could do with reasoning. It's just, instead of using an AGI, you're using like a hybrid community. So then the next thing is estimation function. So I think this is one of the ideas that helps make this work. I mean, this gets into squiggle. So basically, right now, there have been a bunch of existing calculators where the calculators basically work is, this is a kind of estimation. So on the left, we have microCOVID, which is an app. You basically enter parameters for the details of an activity they're going to have, and then it gives you an estimate of the number of microCOVIDs, or like 1/1,000,000th of a COVID that people may get an expectation from that event. And then on the right is a tool to estimate the costs of eating different animals, where you give it parameters about what you believe, like your specific beliefs about the animals. And very similarly, there are time series forecasts online pretty frequently. So this is one, like during COVID, there were a whole bunch of time series forecasts of the future of COVID projections. One challenge with these tools is that each one of them is basically its own widget. So a lot of how they work is that they would use Python or something else on the back end in order to calculate interesting parameters. And then they use some like custom JS widget that's embedded in HTML in order to make those available to the public. But the downside of this is that it's basically impossible to use these from other functions or other programs. Like I can't write a script that then takes in one of these people's values unless I like read their custom way that they built the code, which is always different. If I wanted to write my own front end for these, it would be very difficult. For the time series forecasts, often the time series forecasts don't have all the data that you need. So for example, in this case, it could just even be a table where it just shows you the 50th and the 95th percentiles. So you don't get the distributions in this case. Typically, time series forecasts give you some very specific discretized version of the time. So it'd say like on the first Monday, 9 a.m. in the day, we'll give you a value. This becomes a huge pain. There's no standard API for these types of things, which means that you can't call it if you want to use it for your own thing. So for example, microCOVID can't call updating COVID forecasts that easily. It also means that we can't aggregate these. So if a few of them estimate the same things, we can't like write an ultimate one that accepts both. And it's also very hard to score, because if you want to roll one of them back in time, that's very difficult. Sometimes they have GitHub accounts where you could actually go through the commits and then kind of manually figure out what the code was in their arbitrary format at that time. But this is a huge nightmare. A few people go through all of that work. Well, hypothetically, a neat way to just store this key information is in code. So in the case of time series, you could imagine a function that basically takes in any date and gives you a number of cases at that date. That doesn't have to be super hard to write. So this is like obviously a very hacky function, but you could have more sophisticated ones. And one nice thing about functions that if you want to, you could just store a lot of variables in them. They could be arbitrarily sophisticated. So in this case, if you want to then have a function that instead of just giving COVID forecasts for one place, you could give it the COVID forecasts, it'll calculate the COVID forecasts for any place at any point in time for some specific time range. And that's just a pretty powerful abstraction. This is another case where like this could also be represented by one function that could be used to create this dashboard, but also could be used easily outside of it. So if we could find some way for these estimation functions to be a standard format or a few standard formats, then basically what you have is a decoupling between like the creation of this type of information and the use of this kind of information, which means that we could use all of these in very similar ways. So every time one of these big estimation functions type things is generated, would very easily be able to use them to create other estimates, to do scoring, to do aggregations. And then that means that we could use these now in forecasting systems. So arguably in the future of Metaculus or other forecasting platforms, one of the things that they should do is instead of only having questions that are either a number distribution or in some cases a simple time series estimate, they could basically give arbitrary function definitions and then people submit functions for those function definitions. That's one main reason why we created Squiggle, which is a programming language for estimation. Very recently, we're working on a project called Squiggle Hub, which should hopefully come out in the next few weeks. And that basically helps save Squiggle models if you want to. Now, Squiggle models are just code. So technically, we have a Visual Studio Code extension as well that people use for big projects. You could just go to the playground and start playing around with it. B equals A times D of T is equal to normal T squared t, and then d. And then you can see that that's like a distribution is a function at any point in time is a probability distribution. So the idea is that people would basically submit these small code snippets as their forecasts. Now, of course, a lot of people are probably going to want to be a bit more sophisticated in that they have some big world model or they're feeding in other forecasts and getting their forecasts out. That's where Squiggle Hub comes in. Instead of having just GitHub, we have our own little platform where people write Squiggle code and then see the Squiggle code. A lot of the purpose of it, though, is for the future, for people to be able to use this to help submit Squiggle code for forecasts, and also to quickly and easily be able to import some elements of some people's code into other functions, right? So if some people come up with risk estimates for the next 30 years, how likely are we to die from these 20 different measures? Someone else could easily import that into their model and then have their model estimate how valuable specific projects are that are estimated to help on specific measures, right? And then hypothetically, you could have triggers that like one day you wake up and get an email that says like based on imports to your model, things have changed such that now you should change your job doing this thing and start a job doing another. But that's probably going to be a bit ahead of us. But hypothetically, you could have pretty powerful setups with code as estimates. Next, relative values. So I think that this is one of the...
May I ask something about Squiggle?
Of course.
Do you have any plans for using Squiggle for building models, that is making inferences from data and not just making predictions where you already have the model?
So it's not made for probabilistic inference, right? It's not, it doesn't do backwards inference. Like forwards inference is pretty simple. That is like a different set of functionality. I think that like, if you want that, we are hoping that people would have a somewhat okay time using this with other programming languages. So for example, if you want to do inference or say agent-based modeling or some heavy duty work, you do that with Python or something, and then try to embed the results, like hash the results as you can and embed them into a function that could be run quickly on Squiggle. So we're aiming for like use cases like that. And then also in this case, Peter Wilderford made a SquigglePy, which is a small library in Python that allows you to use similar syntax in Python. Python has a lot more infrastructure for doing hardcore modeling. However, Python is hard to access in JavaScript for multiple reasons. So I think it might make a worse easy estimation submission format, but it is a pretty good modeling format. So there may be cool ways to combine them. We'll see in the future. So the next thing, relative values, which is like one type of format I'm excited about, but we'll of course see how well it does. There's an interesting question here, which is that some of us are utilitarians, but we still don't have utility functions that are formalized. So there's kind of an interesting state. There's a comment about using some of Python and JavaScript. I think that there is functionality on its way. It does seem like it's becoming easier to do, but it is still kind of rough. My impression is that it's going to be fairly messy, and JavaScript really didn't have anything. Like we probably want some JavaScript infrastructure for this kind of thing anyway. Even if we have Python, we'd want to visualize it and stuff in JavaScript. So a lot of Squiggle is just making sure that we have primitives for things like showing distributions and stuff. We have to do a lot of the stack, unfortunately, for the language, but I think some of that is useful. But we'll find out more later. So relative values, there's a question of why don't we have empirical utility estimates for many things that EAs care about? This is especially true in long-termism, which often right now has not been getting that much explicit estimation for the value of different long-termist projects. It's like kind of interesting given that EAs pride themselves so much being quantitative. But I think one big reason is that units kind of suck. So in health measures, we have qualies and dollies. In long-termism, we don't. And in health measures, like things that don't fit well within those two become quite a pain to use. Functionally speaking, when you try to estimate things, when you don't have amazing units for them, it becomes quite a mess. And then if you try to estimate things are very different to each other, the only way to kind of do it is to have like one unit for each subcluster. But then you need to impose structure that you need to have this like very rigid frame for which types of items could be measured using what kinds of units. And this just becomes pretty messy. So I think a big reason why we've been having trouble with long-termist stuff is because we've been fighting having to use units in the conventional way. So instead of just explaining next steps, I'll just like show you what I mean by that. So we've been working on an app to help demonstrate relative values. In this case, relative value functions are when you have functions that could say for any two interventions I care about, I could tell you how much better one is compared to the other. More specifically, it's one that would say, here are the joint densities of the two in some unitless format, and then I could divide them. So we've been trying to help visualize this. So this is like a super hacky example, so don't trust the numbers too much. Isn't a unit of X risk decently quantified? So I'll show you what you mean. People have been talking a little bit about microdooms or microtopias. A microdoom is a 1/1,000,000th of a chance of the world ending. A microtopia is a 1/1,000,000th of a chance of the world just being saved for indefinitely, having a great time. A universal microtopia here is, imagine there aren't aliens, we get to harness the entire universe eventually. So one microdoom over here we're saying is like -0.2 microtopias. But then separately, we care about estimating a lot of different types of clusters of things. So we may want to say like how valuable is an open field dollar in 2020 compared to 2023, compared to long-termist LTFF dollars in different years, compared to animal funds dollars. Now, one thing for all of this is that you do need a value specification. So you do need people to agree on like, this is how we're defining value. So in this case, this is coming from a long-termist lens. I'm trying to estimate what some clusters of long-termist evaluators are going to say if they have to judge two of these things. So that's one reason why the animal funds are not ranked so highly. I have a specific item for global health and development, just the direct impacts, not flow-through effects that may help for X risk for some reason or another, which in case may be much lower, depending on how you do the math. And then separately, we may have estimates for like how valuable human qualities are compared to animal qualities. And like a pig quality compared to a pig life, compared to a pig farm life, compared to 100 calories of food, kind of assuming that it comes from a farmed life. So all of these are very different clusters of things. And often we have a fair bit of information about how good one is compared to the next within a cluster, but we don't have between clusters. So for example, we could say that a human quality is probably kind of similar to human life, right? So in this case, I'm comparing everything in terms of cow qualities. But if I want to compare things in the human lives, one human life may be about 60 human qualities, or maybe about 4 cow lives. This was looking at some tables by rethink priorities. This, of course, in this case, we're just looking at the welfare gains from this person without any of the harms that they produce. Those, of course, would be things that would be nice to be estimated in other estimates. But one thing is that if you were to try to estimate all of these items, the quality items, the like LTFF funding items and the Macrotopia items on any one scale, it would be quite a pain. But between each cluster, we do have a fair bit more understanding of how good they are compared to each other. So if I were to try to make a big grid of this, there are a few visualizations that we've been playing with. This is like the big grid of everything compared to everything else. And we basically have a clever function that could say for any of these two, give me one divided by the other. In this case, the numbers mean the 0.9 is like the median, and then the 0.15 is the orders of magnitude from the 5th percentile to the 95th percentile. This should probably be half. This is still like very much a work in progress, but I think you could get the basic idea. It's white if there's a relatively low amount of uncertainty, and then it's red if there's like a fairly high amount of uncertainty. So you could see that if you compare LTFF dollars to other dollars, it's pretty well understood. When you start comparing them to like animal funds dollars, it starts becoming a fair bit more uncertain. When you start comparing them to like microdooms, then you start dealing with like 3.7 orders of magnitude of uncertainty. And then with like human qualities, it's like 16 orders of magnitude of uncertainty. So this, of course, is like making a very big assumption about like this. In this case, I've used numbers to assume that open fill is like very effective at helping microdooms, and a microdoom is equal to many human qualities. Of course, other people could come up with their own code. In this case, the rows basically mean that one open fill $22 is equal to 0.9, one open fill 2023 dollar, or one open fill dollar in that case is equal to about like 10 to the negative 14 microdooms.
So everything that's on the horizontal axis is also on the vertical axis in this case.
It's all basically
that was
flipped but
confusing to
inverted.
me.
We do have a little tool to help with that. So you could do this to cancel
If that
half of
comes
it
from-
out. And then we have this
just in
cluster.
the comments, if you
Yeah.
wanted to get into
Yeah.
it, I was just wondering, so you had mentioned that,
Yeah.
these are based on your default moral parameters and maybe some other epistemic parameters. Have you thought about a way of sort of labeling that more clearly? Just make
Yeah.
it clear based on X parameters all stated here. Maybe it is clear and I haven't seen it. To a way that people could swap out different sets of possible, parameters as recommended by so-and-so or put their own ones in.
Yeah, I think those are great questions. On the first, I mean, I imagine before we actually submit this to be public, there would be like a huge red box on the top saying like, warning, this is very speculative, especially at this point. The value specification has to be very specific. So in the case of the value specification, meaning like my specific views, That's very different from the value specification, meaning like this is a formal forecast submitted for what I predict for like these 3 experts are going to say in the future. Like I'd hope that we could do that. With a lot of this, I'd say like this is very much like a first step. Like there's definitely ways to make this much more complex. It is programming, so you could just add as much complexity as you like. So for example, like these could take parameters. So it's kind of silly to have like chicken 100 calories. Like you should just be able to say chicken like n calories and then pass an n. Hypothetically, a lot of these, instead of having discretized items, you should be able to have parameterized items that could accept continuous parameters. And then that from things like that, if you want to say something like maybe you have a function that takes in parameters about the specific viewer. So maybe it could accept a parameter like on a 1 to 10 scale, how much does a viewer like, long-termism versus short-termism, or if we could parameterize like their perspectives, we could enter that in such functions and then calculate estimates for what like individualized estimates for them.
I just think that'd be a really good feature if someone could say, I'm going to submit my moral parameters, and then I could be like, I'm going to plug in Ozzie's moral parameters. And maybe they have a little statement explaining their moral parameters, but I'll shut up. That's, something you'll probably build in later.
No, I totally agree. I mean, I think a lot of it is just about, first we need to make sure that this stuff is like pretty usable end to end. And then we need to figure out how to make it better. Just FYI, this is our view of the joint densities of any 2 parameters. So maybe like one fund compared to the next. In this case, there's something fun going on there, but you typically have some joint density, and then this is meant to be the probability distribution of one divided by the next. That is super noisy right now because the numbers are gigantic in some of these cases. But we are, of course, working on doing a better job when handling large numbers. That was a lot of the challenge with this app. This is a force diagram where we basically, for any pair of items, we say how uncertain was that combination. And then that's equal to the force that those items are away from each other. And when you do that, you see some natural clusters of them. So over here, blue are the funds, red are the different like macro variables, and then green are most of the animal variables. Although this blue one is just the direct effects of the global health and development on individuals. And then if you want to like look at that more, you could see that. So over here, salmon is pretty close to shrimp, as would kind of make sense. There are many items that are directly on top of each other because of how similar they are, which makes this a bit harder to read. But one interesting thing here is that I think it should basically be up to the forecasters to decide how clustering happens. And then people should be able to make that visible once they see those values. It shouldn't be something that's like predetermined by, like if we would have used units for this, we could have tried to figure out what the clusters were in advance and give a unit to each cluster. But then in that case, we would have had to like make assumptions, and it would make it difficult for the forecasters to go any further in their clustering. So what's being clustered here? Basically, health and animal fund are very close together because the distance, the uncertainty of one, when people estimate one divided by the other, it's a pretty certain distribution compared to when people estimate one salmon life versus like one microdoom. That's a very uncertain thing, like 14 orders magnitude of uncertainty. So those would be like much further away from each other than these would be. I'll send you the link to this. And then all of this comes from the editor. So the way to generate all of this is basically by writing squiggle code. So you basically say, I think that this parameter is equal to this combination of other parameters. And you do that a bunch of times. And you make sure that to track correlations between those items. So if you divide 2 things that have the same intermediate nodes, a lot of the same intermediate nodes would cancel out. And that's how you get like the nice uncertainties for things that are very similar to each other, even if they may go through a few very uncertain transformations on the way. So the hope here, of course, is that we could treat these as estimation functions. So other people could then import this and do what they like with it as they want. Also, because they're standard functions, you could also forecast and aggregate on them. So if we had 10 forecasters all forecasting their own tables, it's pretty easy to then like, whenever someone wants a specific value, we like ask all of their functions for that value and then like average them all out on demand. And we could also score them. So the way that would work is we basically have a huge function of items. We ask forecasters to estimate every combination of items. And then we kind of randomly choose 5 combinations and then have expert panel evaluate their best guesses on those combinations with a fair bit more time. And then the forecasters who did the best job, where their function best predicted what those panels would say, they get rewarded. So this is a way for us to take Metaculus and apply it to just evaluate how good everything is in effective altruism, arguably. There are, of course, some challenges in making that happen, but I think this type of system gives us a way of like figuring out what at least like one way of doing it would look like. So the benefits of relative values allows it for a high ceiling of information storage. Like you could start clarifying all these like subtle clusters that you wouldn't get with regular units. It's very easy to get started. You don't need to wait for a great unit to emerge before you could just start estimating the different values of things, and then units could come later. So it's great to look at things in terms of units, but you shouldn't force estimators to begin using units because they have a lot of information they could get started with. And then they're pretty easy to compose. In theory, like hypothetically, people could have relative value functions that estimate very different parameters, but on similar value definitions or value specifications. And as long as that happens, it's possible to then compose their functions as long as there are some overlapping elements. This, of course, is an approximation, but it could still be good enough for decision making. There are a lot of things to evaluate. I'm not going to spend much time on this. So I think relative values basically have a bunch of nice advantages over doing things in other ways. And then joint densities, which are a bit more information, which helps deal with negative numbers and zeros. So big picture thoughts, maybe super quickly. If we have a notion of like items that are very similar to each other, in any situation, we have like a bunch of existing forecasts that are good with different amounts of quality. So some items on Metaculus are forecasted much better than other ones. There's just a lot more time and attention spent on them with better people. And then similarly, for any question that people have, it's going to be similar to some Metaculus questions. Similarly, with the relative forecasts, there may be projects very similar to ones that have been forecasted, which would be convenient. So we want to optimize these distances to make sure that for all the questions that people have, we have questions that are pretty similar to, that are done pretty well. And there are ways to quantify this. This is a quick detail on what that more specifically could look like. In the future, I imagine ChatGPT is going to be used for like the final stretch. So when someone has a question, basically they'll ask it to ChatGPT, and then ChatGPT will look into the existing forecasts to see what the forecasts say. It'll find the most related questions, and then it'll figure out how to adjust them in order to get what the user cares about. So it'll act as glue, which basically means that in the future, we'll probably have LLMs help write these big functions. And then once we have the functions, and once we have these like ecosystems of functions that are all relating to each other, LLMs could help us take that and then get that last mile to make sure that whatever question someone has, hopefully there's something pretty close. And then hypothetically, it'd be amazing to have a world where we have explicit decision utility functions that we could say for anything in EA or anything in the world that we care about, how valuable is it, especially if it's relative values, we could be precise with that. It'd be great if we could, if the systems were strong enough, it may be cost effective for us to spend very large amounts of money on them as like big macro projects or mega projects. Hypothetically, at some point, it should be possible to say, like, have specifications, like for almost any question that people are thinking about, we're able to generate a corresponding estimate that's about as good as some creative quality, just very quickly using some combination of language models and like larger infrastructure. And then in the end, maybe like some other ideas would be things like instead of LLMs playing, or like reinforcement learning agents playing Civilization 4, maybe this kind of infrastructure could do a decent enough job to be pretty competitive in some of these games, just to prove that this type of procedure works. And the nice thing about this is that it can be zero shot. It's just people thinking using the rules of the game, which means it could be applicable to many situations where you don't have that much data, including most human situations. So that's a super high level view. Happy to take any questions.
Nice work.
So thanks, Ozzie. This is really interesting presentation. And I agree, actually. It's kind of troublesome sometimes when EA is talking about futurism, but really it's more of like a quality thing and not really much of a quantity thing. So that was really cool to introduce that idea of utopia units and doom units. I guess my question mostly comes on the heels of how we can use this and who this primarily is useful for in this group, because I tend to think that a lot of times the estimation forecasting side of things is for more product managers, but I can also understand the usefulness of software engineers to be able to do many of the kinds of techniques that you introduced and brought to this presentation. I was just curious if you could maybe speak a little bit on the practicality part of this and how we can use these tools going forward.
It's tricky to figure out exactly where to start. With utility functions specifically, or with things like relative value functions, I think if we had decent relative value functions within EA, that'd be useful in a few different places. Some of this is basically a question of how valuable is it for people to know what's important and what's not important. And I think that shows itself, like having more clarity there, where this is one way of getting clarity, helps for a few different types of decision makers. On one hand, it helps for grant makers to decide what to give money to. On the other hand, it helps organizations to figure out what they should do. So if organizations see that some organizations are surprisingly effective and some ones are also surprisingly ineffective, they could take note of that and then try to copy what they're doing, which is what we want. In a similar way that like once GiveWell really started evaluating organizations, new organizations were able to learn from what they said and then craft things very specific to that. When it comes to individuals, of course, if you're trying to figure out where to be effective, if you could just like see tables of where effectiveness exists, you could just go to those corresponding organizations and have those corresponding skills. I think generally when you don't have great estimates, what happens is that people try gaming mediocre signals, right? So like in this case, if people know that there aren't great estimates of the value of their work, they may assume that people are going to be influenced a whole lot by just what gets seen. So they, for example, may talk very loudly and may try to hack credibility in other ways. But if we use the right procedures, we should make sure that it's very hard to get past specific forecasters if the forecasters are like good enough and spending enough time, which will mean that like the whole system, ecosystem as a whole, will be aligned to be better. Of course, this does come with a lot of visibility that people may not want and stuff. When it comes to engineering, there is like a whole different set of forecasts I'd like for engineering purposes. For example, it would be very interesting to see for every NPM package, how likely it is to get hacked in the next few years. Like that would be like a very straightforward forecasting challenge that would be a scalable one. Similarly, I'm very curious for a lot of stuff like should we use React? Is React going away? Like which tools and techniques are going to be popular or going to be effective? Another cool thing that you could do with utility functions, especially as you get to have language models do a lot of the work for you, is just to estimate the value of all your commits, right? So you should be able to say like how valuable all the tech development itself is. And hypothetically, that should be able to align tech development to do the most useful parts of it and do it more effectively. Of course, this is probably a few steps away, but I think it is like an achievable thing, hopefully before AGI. Or at least like it's kind of straightforward to me how one could kind of go about this. It's not straightforward to me how expensive it would be. And like, do we have the time to actually do it before even better methods come out?
I have a question. What do you think is the barrier to increasing epistemic quality in broader society? I understand that this would differ country to country, or like perhaps there's also generational differences in people's willingness to come face to face with the truth. But I'm curious if in your experience, you have found any tools or exercises or rationality practices that are helpful for getting people started, getting especially like groups of people on this journey.
This is a very complicated question, or there's just like a lot of different approaches. The approach that I like the most is spending $100 million on software and having that create institutions that just tell people the correct answers on a lot of things, which should help. It's not about like replacing what they think, it's about getting them a few steps higher from which they could start making other choices. So functionally speaking, just teaching people things is incredibly hard, right? It's just very expensive to teach people on a large scale. So you want to minimize the stuff that you need to convey to them. So for example, Our World in Data is a pretty good site where we're able to use like some engineering, and people are able to understand the results of Our World in Data pretty easily, but they don't need to understand all the inputs to those results. Similarly, like data science is a case where we're able to get like a specific professional class of data scientists to produce useful results that are able to be very minimal, where like the results are very easy for people to understand when they get to the end. But like there's a lot of background for those data scientists to learn, but like they're able to deliver the output in a decision relevant way, in a very concise way. So I very much like that type of format. Of course, there are a lot of different ways of going about it. We also, of course, need to figure out how to actually make those teams of data scientists in the future, so to speak. So there are a lot of questions on like how to best train those people and what epistemic environments they need. Bridgewater is a case of a company that has like very good, or had very good epistemic norms, supposedly, about being like very candid and very open. I imagine we could have people go further, right? But there's a lot to discuss here. I think one issue that I see some EAs have is I think in the old school rationality community, there's a big focus on very personalized epistemic training. And the idea was that every person would get this kind of epistemic training. And I think that is not super cost effective, as opposed to trying to batch it into some people who could give things in like very high value per unit time increments.
Thank you. I appreciate that. Was a very comprehensive answer.
There is a question in EA, like, can we make the EA community more candid and open? Because my impression is that the EA community is pretty good for American communities and Western communities, but we should be aiming for much higher than that. Like the best of like common American communities just isn't that high in what people are willing to accept and go along with. So I think hypothetically, there's like a high ceiling for how far we could go.
Mm-hmm. Interesting. I wanted to +1 to something that you said. And I think it's interesting the role that different institutions outside of EA could play. So you mentioned like company, like Bridgewater, for example. This is not an EA institution, this is a hedge fund, but Ray Dalio has a really interesting perspective about AI. And he is very like, I think, aware of its potential capabilities, which is quite interesting, especially given like his generation. But yeah, I do think it's kind of interesting the role that EA and also then just like other like, you know, capitalist organizations, e.g. workplaces, may play in improving decision-making ability. Like how do you make that a norm in other places beyond these niche groups?
So if you had good enough epistemics yourself, I think you'd be able to figure it out effectively. I think that a very easy place for people to wind up and be sad is just to realize it's hard to make institutions have better epistemics and then kind of give up. But I think people with that don't have the best epistemics. Like if we had cost-effective epistemics, so if we could do estimation at scale, what we'd be doing? Would be making gigantic tables of every government and sub-government and like subcommittee, and like how receptive all of them would be to different kinds of decision making and different kinds of influence, right? It would be finding the very, very best groups in the world that would be the best ones to target, and then would be making things specifically for them. So that could be that there could be some very specific committees and local government institutions that are really curious which construction contractor they should work with, and are really open for actual information here. So if we have forecasts specifically made for these groups, then like effectiveness could get started, right? So the government is gigantic, and the naive ways, if you spend 20 minutes thinking about it, are not going to work. But if you are serious about using epistemics as a medium to improve society, then you just have a very, very large solution space. Meaning that if you're okay being very deliberate in how you deal with things and selective in the projects that you take, my guess is you could be pretty effective.
Yeah, I think so too. I think there's a secret cause area in convincing GiveWell to incorporate data visualizations. So if anybody has friends at GiveWell, tell them that, you know, the executive summary is so called for a reason, because executives are busy and they need a summary. So anyway, that's just my quick gripe before we go to the next person. Michael, you had a question?
Yes, thank you. I think, Ozzie, and please correct me if I'm mistaken, that your agenda seems to be focused in practice about the forward reasoning part and doesn't seem to speak much about the research part of epistemics, that is, finding out how the world works and closing the gaps, the huge gaps in human knowledge, particularly about anything in social science. And I was wondering whether Curie is dealing with that in any way, or is that just out of your budget and your resources?
Arguably, all of thinking is like a gigantic box. And like trying to make fundamental progress on a whole lot of that at the same time is a very, very large project. I think a lot of what Metaculus is doing is kind of this more narrow subset of strategic type thinking and prioritization, where you have information that you're just trying to like improve your estimates by a fair margin, right? But it's kind of a similar, straightforward procedure. Similar to a lot of hedge funds basically kind of know that like, oh, if we could have someone who's like this smart enough in this market and give them like $10 million, they could make about this much money. So they have like a pretty decent understanding of how to apply well understood amounts of units of cognition onto specific types of problems in like decently effective ways. These people are not trying to come up with like tremendously new innovative branches of mathematics or understanding how the world works in like incredibly novel ways. They're just trying to do these like semi-repetitive forms of reasoning pretty well and cost effectively. So a lot of our research is just trying to scale this kind of concrete not super wide type of reasoning, and just making that much more cost effective. So that's not going to solve a lot of profound questions. All that said, if you're able to be kind of okay at reasoning and not be overconfident, there are ways that could help with profound questions. For example, if there are like 20 different research directions that you could choose to make profound insights, this could help you prioritize which ones of those are going to be exciting to spend more research into. But then once you actually make that decision, you probably would want to send in more of a domain expert into that area. Another aspect here is that forecasters typically, they can't be domain experts in every field. So you typically don't expect forecasting platforms to make fundamental domain breakthroughs or be able to say that much about areas that require many years of insight or like of background to understand. But I think that there's still a lot of value to be had by doing a pretty good job with this more narrow thinking of just like very smart generalists or people with like a collection of common professions like economics, engineering, things like that.
Thank you. I'm not sure I got your thoughts precisely, but maybe we'll save that for another conversation.
It's a tricky topic.
I think we'll let this be the last question.
Firstly, I want to say I'm a massive fan of yours. I think Squiggle's a really excellent programming language, and I'm glad it exists in the world.
Thanks.
So, two parts. First part is, have you given any thought to what is the most complex model you can make? Like how this scales before you end up with prohibitive compute costs in order to calculate this?
Yeah, that's a good question. So one thing is that for any sophisticated Squiggle-like system, you'd probably use a whole lot of caching. So you can be kind of clever about what inputs people are going to repeatedly want. And then the way that I imagine this working at scale is that we have a whole bunch of Squiggle functions and understandings of how important which ones are. And we're kind of continuously caching the ones that get called often and the ones that seem decisive as part of it. So I think you could be very clever about it. And I'd also flag that I don't know how deep these models need to go. Like it's possible that they could just be very wide. Often I think there are a lot of important parameters in the world that you could solve with like 5 or 6 total multiplications or something, as long as you choose the right strain of multiplications. So my impression is that with a relatively low amount of depth, you could get pretty far. Another thing I'll just flag also is that, again, Squiggle functions are meant ideally as caches, right? So if you do have to do some really deep thinking, hypothetically, you do that using other platforms and then cache the results and then submit something that could be run much faster, but could still express complex domain. So it's not obvious, of course, how far all of these could go and at what point this may different, like there are definitely like a lot of technical challenges to doing this well at a big scale. I think we could get pretty far. I don't know that much about the details. My guess is that we're going to have challenges of individual, like a lot of the bottlenecks are going to come from it's just expensive to make the technology good enough. Like we have a small team actually doing a good job at like a whole, programming language and programming platform for that language is a lot of work. Getting people to write that language is a whole lot of work. And the question is like David asked, what do you mean caches? In this case, it just means that we run the function and save the results of that function so we don't have to run it again. So if people call the same function a lot of times, we just like run it. And we could also run it with way more samples that way. So typically a function would be run with 1,000 samples. In this case, we say like, oh, this specific line is used a whole lot. We'll just like run that with a whole lot of samples and then save the results. Hypothetically, you could also have wrapper functions that like do more complex caching mechanisms and like try to cache a broad function space, but that gets to be more messy. It's kind of fun because like, a lot of this is like, we're trying to take human questions and translate them, solve them using these huge technical solutions. But I think you could get pretty far. But it is a lot of technical work. We're kind of giving you a demo, but to do an amazing job, you'd probably want a lot of engineering to be done.
And the last question is about dependencies through a code base. So good old-fashioned AI and parametric statistical models have an issue where they're brittle, where if you make an error in the logic, like 100 lines of code back, that causes your downstream results to also break. So there's a lot of redundancy. For example, in like a transformer, there's like a lot of redundancy. How do we ensure that as we make these squiggle models bigger, we can keep a modular approach where breaking one part doesn't break the whole thing, or you have like error correction or redundancy within your model?
So the thing that I am interested in is using, I think that if we're able to use functions as forecasts, we could have empirical information for this. And that's one reason why I'm excited about that. So like basically, what I don't want to see happen is like one person makes some gigantic mammoth model that's like 50,000 lines of code, and it is just their own model end to end, because then I'd expect to see issues like this. Like you said, I think components is kind of what we want to aim for. Some really nice type definitions that could be consolidated as forecasting questions and then provided by different forecasters. So I think if you can only go so far in one module, then the chances decrease. If multiple people are incentivized to forecast the same item, and you're able to get a few semi-independent estimates of that like key component of the item, then you're in a much better place. And then hopefully we'll get data about how good people are at forecasting using functions and what the error rates look like, and if there are automated approaches that we could do to this kind of estimation. If we're doing a good enough job, then what people would do is automatically, like, if there are enough incentives at play, people would be writing ML agents to try to detect errors in each other's code and then like write adjustments and forecast them and then get paid accordingly. Of course, in order for that to work on a nice scale, it would be great if things were well parameterized and componentized so that we could get pretty far by a few pretty concrete building blocks, each one of which is understood, appreciated, and well voluminous on a forecasting platform.
Yeah, I completely agree. It reminds me of the left pad module as well, and having a GitHub sponsors type approach might be very useful there. Perfect. Thanks very much.
I agree. Yeah, thanks.
Well, another huge thank you to Ozzie for the presentation. And thanks everyone for coming.
Thanks again for hosting, for the questions.
Bye, folks.
Thank you.